A windmill, commonly referred to today as a wind turbine, is a device that harnesses the kinetic energy of the wind to generate mechanical power, which can then be converted into electricity. Wind turbines are a key technology in modern renewable energy production, and they vary in size and design depending on their purpose. Here's a detailed breakdown of how they work and the key components involved. Structure and design. Tower. The wind turbine is mounted on a tall tower, usually ranging from 40 to over 100 meters in height. The height is important because wind speeds increase with altitude, so a taller tower allows access to stronger, steadier winds. Blades. The turbine typically has 2 or 3 blades made of lightweight yet durable materials like fiberglass or carbon fiber. These blades are aerodynamically designed to catch the wind. The blades are the most visible part of the turbine and can be as long as 80 meters in modern turbines. Nacelle. This is the housing at the top of the tower, which contains the major working parts of the turbine, including the gearbox, generator, and controls. Rotor. The blades are connected to the rotor, which is the rotating part of the wind turbine that turns when the wind blows. Working mechanism. When the wind blows, it creates lift, similar to how an airplane wing works, on one side of the blade, which causes it to rotate. The stronger the wind, the faster the blades turn. Rotor and shaft movement. The rotating blades are attached to a central hub, rotor, which in turn is connected to a low-speed shaft. The rotor and low-speed shaft turn slowly, but with significant force due to the large surface area of the blades. Gearbox. In most large-scale wind turbines, a gearbox is used to increase the rotational speed of the shaft. The low-speed shaft turns at 30 to 60 rotations per minute (RPM), but the generator needs a much higher RPM, about 1000 to 1500, to produce electricity efficiently. The gearbox converts the slow, high-torque rotation of the low-speed shaft into faster rotations for the high-speed shaft. Generator. The high-speed shaft is connected to a generator. The generator uses electromagnetic induction to convert the mechanical energy from the rotor into electrical energy. In simple terms, the moving shaft spins a rotor inside the generator, and this motion creates a magnetic field that induces an electrical current in coils of wires. Power conversion and transmission. Transformer. The electricity produced by the generator is in the form of alternating current, AC, but at a low voltage. A transformer, either inside the turbine or at a nearby substation, steps up the voltage to match the transmission grid's requirements. Control systems. The turbine also has several sensors and control systems that optimize its operation. Yaw system. Keeps the turbine facing into the wind by rotating the nacelle. Pitch system. Adjusts the angle of the blades to control their speed. Grid integration. These are the most common type of wind turbines. They have a horizontal rotor shaft, and the blades rotate around this shaft. They usually have 3 blades. Vertical axis wind turbines, VAWT. These turbines have a vertical rotor shaft. They don't need to be oriented into the wind, so they work well in turbulent conditions like urban settings, but they are less efficient than HOTS. Efficiency and energy production. Modern wind turbines are incredibly efficient, with some capable of producing between 2 to 12 megawatts (MW) of power. For perspective, a single 1 megawatt turbine can generate enough electricity to power around 300 homes in a year, depending on wind conditions. Capacity factor. This is a measure of how often a wind turbine produces electricity at its maximum capacity. On average, wind turbines have a capacity factor of 30 to 50%, meaning they generate power about 30 to 50% of the time, depending on the wind availability. Advantages of wind power. Renewable. Wind energy is a clean, sustainable energy source. As long as the wind blows, turbines can generate electricity without depleting resources. Low emissions. Wind turbines don't produce any greenhouse gases or air pollution during operation, making them an environmentally friendly alternative to fossil fuels. Cost-effective. After the initial setup costs, wind energy has very low operational costs. Once installed, wind is free. Challenges. Wind isn't always blowing, so wind power can be unpredictable and requires backup power sources or energy storage systems. Noise and aesthetic impact. Wind farms can generate noise, though modern turbines are quieter than older ones. Some people also find wind turbines to be visually unappealing. Wildlife impact. In certain areas, wind turbines can pose a threat to birds and bats, although newer designs and proper siting of turbines can reduce these impacts. Uses of windmills in history. Before the development of wind turbines for electricity, windmills were used for mechanical tasks such as pumping water or grinding grain. Traditional windmills had a simpler design, with blades or sails that turned a grinding stone or water pump. Wind turbines today represent a modern evolution of the traditional windmill and are crucial for expanding renewable energy capacity globally. Which countries are using windmills, and what have they achieved? The biggest wind power producing country. Let's start with the country with the highest wind energy generation. China. At the top is China, leading the world with a massive 328 gigawatts of wind energy installed in 2023. United States. In second place, the United States contributes 141 gigawatts to global wind energy. Germany. Germany, a global leader in renewable energy, ranks third with 66 gigawatts of wind energy installed. India. India comes in fourth with 44 gigawatts of wind power, pushing forward its renewable energy goals. Spain. Spain, a renewable energy pioneer, produces 31 gigawatts of wind energy in 2023. United Kingdom. The United Kingdom continues its offshore wind expansion, generating 28 gigawatts of wind energy. Brazil, leading the way in South America, ranks 7th with 23 gigawatts of wind energy. France, known for its commitment to clean energy, has installed 21 gigawatts of wind power. Sweden rounds out the list with 15 gigawatts of wind power in 2023. Outro. In the vast and endless energy of the wind lies the power to reshape our future. As the blades turn, they symbolize more than just energy production, they represent hope, sustainability, and a commitment to preserving the planet for generations to come. Wind power isn't just an option, it's a necessity. It's time to embrace the winds of change and build a cleaner, greener world. We hope that you will like this valuable information. For such as wonderful information, support us by liking and subscribing our channels. Don't forget to press bell icon and your valuable comments.